Yeah. Let's start the transformation of a function. So under transformation, first thing which we have is what? Translation. Okay, so how does translation work? Now translation can be left, right, up or down. So whether that means it can be categorized into two different things. One is horizontal translation, or the next thing is what? Vertical translation. Under horizontal also you can have two different things. You can move either to the left or you can move what? To the right. Now, when you say you are moving to the left, how do you represent? You represent it by f of x plus a. So you are moving a unit to the left. If I write f of x minus a, you are moving a unit to the right. The same thing can be written in the vertex form by saying minus a 0. That means on the x-axis, you are moving a unit to the left. Or if you move to the right, you write what? A 0, which means a unit to the right and nothing changes on the y-axis. Okay.
Okay. Yeah.
Now, similar to that, if you talk about vertical, under vertical, you can move either up or you can go what? Down. If you say you're moving up, it is f of x plus a. If you're moving down, then that is f of x minus a. In case if I want to write this in the vector form, then I have to say 0 a. Here I have to say 0 minus a. Let's say what impacts it actually makes. So let's assume that there is a random function f of x on which we have a point having coordinate 6, 2. Okay, and I'm saying that I'm doing f of x plus 2. So when I say I'm doing f of x plus 2, it means you're moving 2 unit to the left. So only the x coordinate will change, y coordinate will remain same. So what will the x coordinate become now?
X
You,
coordinate.
yeah, you are at 6, 2. You're moving 2 unit to the left. So 6, 2 will become what?
8, 2.
Brother, you're moving
Huh?
2 unit to the left. It's 2 unit to the left.
Oh,
It's 2
4,
unit left.
2.
That will become 4, 2. Likewise, if I do f of x minus 2, so it's 2 unit to the right. The point will become
Uh, 8, 2.
8, 2. If I say f of x minus 3, you're moving 3 unit to the down. So the point will become
6, comma minus 1.
6, minus 1. Very good. Now if I say f of x plus 1, you're moving 1 unit to the up. The
6,
point will become
3.
6, 3. This was the thing when we were playing on a function, but not necessarily all the time we'll be playing on function. What if I play on some we were playing on a point, now we have to play on function. So let's say you have f of x is defined as x plus 3 the whole square. If I ask you to find f of x plus 2, what will I do? I'll replace x by x plus 2.
X
Yes
plus
or
2.
no? So this will
Yeah.
become x plus 5 the whole square. If I ask you to find f of x minus 3, you'll replace x by x minus 3. So it will become only x square. Do you agree?
Yeah.
If I ask you to find f of x plus 3, this will be what? X plus 3 the whole square plus 3. If I ask you to find f of x minus 1, this will be what? X plus 3 the whole square minus 1. Is that clear?
Okay. Yeah.
Now, what if I ask you to name the transformation? So basically, I'll give you two different functions. One is, let's say, f of x, which is x square, and the new function, which is g of x, that is, let's say, x plus 3 the whole square. Can you name the transformation which is happening from f to g? What am I doing to get g from f? Which kind of transformation?
F of x plus 3.
So what is it? Name it like verbal method. It's moving 3 unit to the left or right.
3 units to the left.
Yeah, 3 unit to the left. So it's a horizontal translation, 3 unit to the left, or I can say translation by vector what? -3 and 0. Do you agree?
Yeah.
Let's take the question number 2. Let's say if I have f of x is equals to x square and g of x is x square minus 4. Can you name the transformation?
Uh, 4 units to the right.
It's not right, brother. It's
Huh?
down.
Oh, down.
Square is not with 4. It's 4 is outside. So it's like on the y-axis. Translation by
Oh,
vector
yeah.
0 and -4. So you're moving 4 units down. Do you agree? Let's take the last
Yeah.
one. You have f of x is equals to x square and g of x is, let's say, x minus 1 the whole square plus 2. Can you say the transformation?
Uh, Translation by z, one, yeah, 1 0, vector
1
1
unit
0.
to the right and
Sorry, 1 and plus 2.
2 unit up.
Two.
Say in words, 1 unit
Yeah.
to the right and 2 units upward. Horizontal translation by 1 unit to the right, vertical translation by 2 units upward. Is that clear?
Yeah.
You sure?
Yes.
Okay, so this was one of the transformation. The second one which we have is called as stretch. So let's understand stretch. Stretch also you can do on the x-axis, that means horizontally along the x-axis, or you can do along the y-axis, which means vertically. How do you recognize whether it is horizontal or vertical depending on the a which is written inside or outside? So when I write f of ax, it means it is horizontal stretch by scale factor 1 over a. If I see a in case of horizontal, it's always up ulta. So when I see a, it is basically horizontal stretch by scale factor 1 over a. But if I see a outside, so a times f of x, which means it is vertical stretch by scale factor what? A. Is it clear? When I see f of ax, it is horizontal stretch. When I see a times f of x, it is vertical stretch. Is it clear?
Yes.
How does it make difference? Let's say again the same point. You have the coordinate 6, 2. If I write f of 3x, let's write in words first. It is horizontal stretch by scale factor what? What is the scale factor?
3 upon a.
1 upon 3. What
1 upon
are
3.
you seeing in place of a? 3. And what is the stretch factor we see? It's 1 over a. So in
Oh,
this case, it will be what?
oh,
1
yeah.
over 3. So
Okay.
what is the new coordinate I'll get?
Uh,
6, 2 will become what? You need to multiply 1 by 3 to the x coordinate, which is 6. So 1
6,
by 3 into 6 will become what? 2.
2.
Will become 2, 2. Let's write the next. The point is same again, 6, 2 only. If I write f of x by 2. Now again, it's a horizontal stretch. How do I know? Because the number is inside the bracket. So horizontal stretch by scale factor. What is it?
1 upon 2.
1 upon 2 is already there. In case of horizontal, as I said, you take the reciprocal of it. So reciprocal of 1 upon 2 is what?
1 upon 2. So 2.
2. So it's a horizontal stretch by scale factor 2. So the coordinate will become what?
2 multiplied by 6, right? So it will be
12, 2.
yeah, 12,
Can you
yeah.
be fast? Moving to the next. Let's say I have 2 times f of x. It is vertical stretch or horizontal stretch? Tell me.
Horizontal.
2 is outside, which means it is vertical stretch. As I
Oh
said, if
yeah.
the number is outside, it's the vertical stretch. This is vertical stretch by scale factor. What? 2. So if the point is again 6 comma 2, it will become what?
Uh,
Now it will impact the
6
y-coordinate.
comma 12.
6 comma
12.
2 gets multiplied by 2. How is it 12?
Or 2 gets, oh yeah, sorry. So 4.
So 6 comma 4. If I write half of f of x, it means it is a vertical stretch by scale factor.
1 upon 2.
So the coordinate will become what?
Uh,
6
1
comma,
upon 2 into 2.
yeah, which is
1.
6 comma 1. Is it clear?
Yeah.
Moving to the last type of transformation, that is called as reflection. Reflection is basically the mirror image. So you can reflect in x-axis or you can reflect in what? Y-axis. So when you reflect in x-axis, see what happens. Let's take the coordinate system. So let's say this is x and y. So somewhere there is a point, let's say x comma y. If I reflect in the x-axis, the image will come somewhere here. So as you can see that the x coordinate is remaining same. So x will remain x, but what is changing? The y coordinate is changing. It is not changing like randomly. Only thing that it is getting negated. So y will become what? Minus y. Yes or no?
Okay.
Because here y is
Yeah.
positive, here y is negative. So the y coordinate is getting negated. So therefore it is minus of f of x. So minus of f of x represents reflection in x-axis.
Okay.
Now, if I have to, let's say if I have to reflect in y-axis, then it will be something like this. The point is here. If you reflect in y-axis, you will end up getting here. So this was x comma y. This will become minus x comma y. Y coordinates is remaining same. The x coordinate is getting reflected. So that means it will become f of minus x. So f of minus x represents reflection in y-axis and minus of f of x represents reflection in x-axis. Clear?
Yeah.
Now the type of sums which they can ask is the combination of all these transformations, and we may need to identify all the transformations. So let's see what happens. Let's take an example where they're asking us to do all the transformation, and we'll take the second example where you have to identify all the transformations. So let's go through an example. Let's say the question number 1. They gave us f of x as what? Let's say x squared. And they're asking us to do the following transformation, starting with first translation by vector minus 2 and 3. Horizontal stretch by scale factor 3. Okay, then reflection in x-axis. Let's say all these transformations are has been asked to apply on the function, right? Let's understand how can we solve this. So while writing the transformation, we need to follow the order in which they have asked us to do. So they said first you do translation by vector minus 2 and 3. So when you see minus 2 here, what do you understand? You're moving 2 into the left or 2 unit to the right?
2 units to the right.
2 unit to the left. Minus sign represents left. And if you
Oh
see
yeah,
3,
on the
that
vector
means,
minus is left,
yeah,
right? Yeah.
yeah, this 3 here represents 3 unit up. So the function will become what? You're moving 2 units to the left, I said. So you have to write x plus 2, the whole square, and then you're moving 3 units to the up. So it will become what? Plus 3. That is the situation, that's the function after doing the first translation. First transformation. Is it clear? Now
Yeah.
next, they are saying us to do a horizontal stretch by scale factor 3. So when I'm saying it's a horizontal stretch, that means the x coordinate will change. Now in case of writing it, we always write reciprocal of it. It is 3. So it will become what? 1 upon 3. So x will become what?
X
1
upon
upon
3.
3 of, yeah, x upon 3. Is it clear? Then they are saying reflection in x-axis. Reflection in x-axis, what happens in reflection in x-axis? Y coordinates gets negated. The whole function gets negated. So this will become minus of x by 3 plus 2 the whole square plus 3. Then if you open it, you'll get minus of x by 2 plus 2 the whole square. So x by 3 and then minus 3. So this will be my new function. Is it clear?
Okay, yeah.
Now the next type of sums which they can ask us, where we need to identify all the transformations. How do we do that? How do we do those? So we have a rule which we need to follow while writing the all transformation. While writing the transformation or identifying the transformation, we always write all these stretches first. Then we write all the reflection if it is present. And at last we write the translation. So this is what we follow. SRT. Sachin Ramesh Tendulkar. This is the order we follow. We will never change this order. All the time when we have to write the transformation, we'll write all these stretches first, then the reflection, and then at the last translation. Let's take an example to understand. So let's box it because this is what the order we're gonna follow all the time. We're gonna write all these stretches. This means stretch. This means reflection. And at last we have translation. Let's take an example to understand. Let's say we have a question, let's say f of x, there's f of x, and your new function is, let's say 2 minus 2 times f of 3x minus 6 plus 4. This is the situation they have said. Now they are saying, let's say this is the new function g of x. Now they're asking us to write down, name all the transformation, which will convert f of x to what? G of x. So rule number 1, before you identify the transformation, your first job is to make the coefficient of x as 1. Make the coefficient of what? X as 1. If it is not 1, make it 1. So what will I do to make it 1? I will take what? 3 common inside only. So if I take 3 common, what do I get? X minus 2. Is it clear to you?
Yeah.
Before you identify any transformation, make sure that the coefficient of x is 1. If it is not 1, make it 1. Okay, cool. Now, as I said, I need to look for all these stretches first. So do I see any stretch? Do you see any stretch? Yeah, 2 is out. 2 is outside. So there's a vertical stretch. So vertical stretch by scale factor. What is the scale factor?
The scale factor is
What number do you see here?
2 minus 2.
Minus is for reflections. Scale factor can have been negative. 2. So scale factor is what? 2. Do I see any horizontal stretch? Do you see any horizontal stretch?
3 into x.
No, it's not. You always write
ulta. 1 by 3.
By scale factor 1 by 3. Okay, stretches are done. Now we have to look for reflection. Do you see any reflection?
Plus 4.
Reflection, minus sign you have to look for.
X minus 2.
This is the reflection. This is the reflection. Either it is minus of f of x or what? F of minus x. Do you see minus sign outside or do you see minus x? Do you see any one of these? Then there's a reflection. So is there
Yeah,
anything
minus outside.
yeah, which means it's a reflection in what?
-2.
Reflection in x-axis or
In
y-axis?
y-axis. Sorry,
Reflection
x-axis.
in x-axis. Minus sign is outside. Okay, so reflection is done. Now, do you see any translation? Last, we have to look for the translation. Do you see any
Uh,
translation?
-2. X -2
So, translation by vector. You're moving
is
to the
2
right
to
or to
the
the left?
right.
2 to the right. And on the y-axis?
Uh, 4 up.
4 up.
Right? Yeah.
Clear. So, this is what all the transformation is happening for 2f of x to get what? G of x. This is it under transformation. Is it clear?
Yes.